Hello students, and welcome to your lab with hydrostatic pressure. My name is Daniel Barnard. I am the fluid technician here at CPUT, and I'll take you through your online lab and the videos for the specific lab. But first let's have a look at the lab guide, and then afterwards I'll take videos of the equipment and how we capture the data. Alright, so this is the lab guide for hydrostatic pressure. Again, you have a table of contents. And then the very first point is the aim of the experiment, of course, and it states very clearly there that we have to determine the hydrostatic force acting on a plane immersed in water and determine the position of where the force is acting. In the second heading, what you need to do, please read carefully through that. All the links and to the videos and data and lab guide will be provided by the lecturer, but you need to read through everything, look at the watch all the videos and all that. Next, theoretical background explains you what the experiment's all about. Then the experimental apparatus, and then there is a picture of the apparatus showing you all the heights and how the apparatus works, obviously with a description of that. And then the experimental procedure is explained, and then the results. The results, two graphs need to be plotted and explains exactly what needs to be done. And in your appendix, there again is a data table showing you the data that you will receive for this lab. First column, mass added, depth 1, depth 2, depth 3, total distance to center of pressure, and the calculated hydrostatic force. And at the bottom, it explains the data you will receive and which data you need to calculate to be able to complete this lab. This is the apparatus for the center of pressure, the hydrostatic pressure lab. And what you'll see here is the shape of the schematic you see in your lab report and the forces that we need to calculate, and the center of pressure is acting on this front face. We're not considering any forces on the two side faces, and we're also not considering any forces on the curved surface, the top and the bottom. Can you tell me why? Now, before we start, we want to make sure that this apparatus is balanced. So we're going to add weight onto it until our apparatus is nice and level. Some more weight. Okay. Alright, so the reason we want this apparatus to be level before we start the experiment is now the weight of the apparatus is counted by the weight through this pivot point. And we can use these black lines at the back, we can use that to line up the apparatus level. Alright. Next, the procedure of the lab. Now that the apparatus is leveled, we can start the experiment. The weight that's current on the apparatus, we don't count that weight because that's the weight that keeps the apparatus in equilibrium. Now if I add weight, it will lift the apparatus in the opposite direction, and then I'm going to fill it with water. Going to fill it with water to counter that extra weight. And again, I'm just using the black lines in the background to get it level. There we go. Now the force acting on this plane at the COP equals the moment caused by this weight. The force on that plane around the pivot point creates a moment which is equal to the moment caused by the weight around that pivot point. In the lab, the raw data we're going to capture is going to be depth 1 is from the pivot point to the water line, depth 2 is from the water line to the centroid of the wetted surface, and then from the centroid of the wetted surface to the COP is a small calculation that you need to do. So you will only receive depth 1 from pivot point to water line and depth 2 from water line to centroid of the wetted surface. The rest the student all needs to calculate. There is some constants in this apparatus as well we need to take note of. The width of this front face is 75 millimeters. The inner radius, that's this one over here, that's 100. The outer radius, that's from the pivot point down to the bottom of the face, is 200 millimeters. And the moment arm is from the pivot point to where the weight is hanging is also 200 millimeters. So we'll continue this process. We'll add another 50 grams of weight. And then we're going to counterbalance it again with water. Let's get some more water. And again, I'll just use the black lines at the back to get the apparatus level. There we go. Then again, for the second step, we'll measure the distance from the pivot point to the water line, and then from the water line to the centroid of the wetted surface, and then from the centroid of the wetted surface to the COP is a small calculation the student needs to do. So what does this all mean? We know the force will act on the point of COP. So if we add depth 1 plus depth 2 plus depth 3, we know where the force is acting. And we know the weight, and we know the distance to the pivot point. So we can use the equation of moments to calculate the unknown force. So this procedure will repeat itself until this surface is fully immersed with some extra additional points as well. Data collected for this experiment will be provided to you by your lecturer. All constants for the apparatus will be included in the data set, and all the measurements necessary for the student to complete this experiment.